So now we're going to take a look at exponents in this section. And the first thing we notice is that this says 4 to the third. 4 is called our base, and the third is called our power, or our exponent. And the exponent tells us how many times to multiply the base by itself. So in this case, it says 4 to the third. That means I'm going to multiply 4 by itself 3 times. So that gives me 4 times 4 times 4. So we're going to take a look at multiplication properties with exponents. So if I have a to the r times a to the s, this means I have the bases being the same and the exponents can be different. What I can do is add those exponents, and that would be the same as multiplying the bases. So an example of that would be if I had 2 cubed times 2 to the fourth, that would be the same as saying 2 to the 3 plus 4. I just add the exponents, or 2 to the 7th. Another example is x squared times x cubed. Well, according to our formula, that would be equal to x raised to the 2 plus 3. Notice I don't multiply these, I add them. That would give me x to the 5th. Now, why would this be the same? Well, let's take a look. Here's x squared. What does it mean to be x squared? It means x times x. Here is x cubed. What does it mean to be x cubed? That's x times x times x. So here I had x squared times x cubed. Well, what does that give me? 1, 2, 3, 4, 5. So that's x to the 5th. That is why that formula works. Okay, here is another formula. You do need to memorize these formulas. This one says if I have a raised to the r power, and then I take that and I raise that to the s power, that is the same as saying a to the r times s power. Well, let's see how that works with an example. So here's our example, 2 cubed raised to the 4th power. So using our formula, that says that that's the same as 2 raised to the 3 times 4, or 2 to the 12th. Here's another example, x squared raised to the 3rd power. Well, according to our formula, that would be the same as x to the 2 times 3, or x to the 6th. Let's see why that works. What does it mean to be x squared cubed? It means I take x squared times itself 3 times. So that gives me x squared times x squared times x squared. Well, what does it mean to be x squared? That is x times x. And here's another x squared. So that is also x times x. And here's another x squared. That is also x times x. And that leaves me with x times x times x times x times x times x, which is x to the 6th. Okay, here we have another formula, and this says if I have 2 bases multiplied and they are both raised to a power, that's the same as taking each one separately and raising it to that power. So ab parentheses raised to the r is equal a to the r times b to the r. So an example of this would be 2 times 3 squared. That means that's the same as saying 2 squared times 3 squared. So another example would be ab squared. That would be the same as saying a squared times b squared according to our formula. Well, let's see why this works. What does it mean to be ab squared? Well, that means take the base times itself 2 times. So that means ab times ab. Well, what does it mean to be ab times ab? I can use that commutative property and rewrite that to be a times b times b. But what does it mean to be a times a? That's a squared. And what does it mean to be b times b? That's b squared. So that is how we show that our formula works. Okay, just a reminder, do not forget, if I have negative 5 squared, we do not square that negative. This is the same as saying negative 5 times 5, which would give us a negative 25. And that is different than parentheses around, which would be negative 5 squared, and that would give me negative 5 times negative 5, and that would give me 25. So let's take a look at some examples. So here are some examples. If I have 5x and all of that is squared, I'm going to say, hey, I need to square both of these. So that's the same as saying 5 squared and x squared. So that would give me 25x squared. So we could then write 25x squared. Here, if I have 4 raised to the 5th power, and that's raised to the 6th power, well, that is going to be the same as multiplying. If I have a power raised to a power, that's what that is. Then I multiply the exponent, so that would be the same as saying 4 to the 30th. Here I have the bases are the same, and I'm multiplying the bases. The exponents are different. I add the exponents. So that becomes x to the 2 plus 5, which is x to the 7th. Now here I have 2/3 cubed. So what does that mean? Well, look, we haven't done this type yet, but I threw it in just to show you. That would be the same as saying 2/3 times 2/3 times 2/3, which would give you 2 cubed on the top and 3 cubed on the bottom. So that would give you 8/27. All right, let's take a look at some more examples. If I have 2x squared, y to the 5th, all of that cubed, I need to take, and then I'm going to multiply that to 3x to the 4th, y, all of that squared. I need to take and apply that cubed to each piece here. So this means 2 is going to be cubed, the x squared is going to be cubed, and the y-5th is going to be cubed. The 3 is going to be squared, the x to the 4th is going to be squared, and the y is going to be squared. Now be very, very careful. This is where students make mistakes. They say 3 times 2 and get 6, but that's not what I'm doing. I'm going to say 2 cubed, and 2 cubed gives me 8 because that's 2 times 2 times 2. The reason students get that confused is because here I'm going to say x squared to the 3rd, and here I do multiply the exponents to get 6, but here I don't multiply that number to this. I have to take 2 and cube it. So please notice the difference. I'm taking each term and cubing it. So that cubed became 8. This cubed becomes 6. This cubed becomes 15 because we use our formula where when we have a power raised to a power, we multiply the exponents. And again over here, 3 squared is going to be 9. I don't go 3 times 2, so I'm going to get 9. X fourth raised to the 2nd power, I do multiply the exponents, and that gives me 8. And y, when I have just a plain y, that's the same as saying y to the 1st. So something to the 1st, well, I would have 1 times 2, and that would give me y squared. Well, now I can take all of this, and I can combine my terms. So I have 8 times 9, that gives me 72. I have x to the 6th times x to the 8th. I have y to the 15th times y squared. So I just used my commutative property and rewrote those in order. Well, the 72, can't do anything more with that. Hey, the bases are the same. I can add the exponents. So I added my exponents. That was the first formula we learned, and I got x to the 14th. My bases are the same. I can add my exponents. I got y to the 17th.